Hi class, today we are going to go over multisensory processing, which is what we do ordinarily, every day, all the time, sensing things in our environment in more than one way, all at the same time. Also, we're going to go over this concept of synesthesia, which is abnormal functioning, but also a very important and interesting concept. So first off, we should consider that the environment is sending out stimuli in all kinds of ways, and our bodies and sensory organs have developed in such a way that we could pick up that sensory information in multiple ways at the same time. If you think about it, we always come back to this survival principle that the best way for an organism to survive would be for it to have the best sensory capabilities for its environment, picking up the most important information about what's going on around us is the most efficient way to do this possible. So it would not make sense for us to first process what we see, then what we hear, then what we smell or taste or touch. We're actually doing all these things simultaneously, and the goal is to do all this processing as quickly as possible and respond appropriately and as quickly as possible. We may not have time to fully analyze information before acting upon it. And finally, please keep in mind that different situations and combinations of stimuli will mean that our sensory organs and brains will adjust to what's going on in the environment, meaning that each task or situation will rely on these different sensory organs and parts of the brain differently. So here are some models for how we might integrate information coming from the sensory organs, then the processing areas of the brain and onto decision making. If you look at model A, decision integration on the left, this model suggests that this information is coming in, but the sensory information doesn't cross over with other information and it isn't really integrated and isn't really used until the brain decides to do something with it. One way that this model might actually be useful is if we think about how much sensory information we're actually taking in all at once and then not actually using, because the brain has already decided that the information isn't really all that useful, so it may ignore it at a less conscious level. The potential downside is that all this information is being taken in, so a lot of energy is being used, but it's not really paying off in the big picture. In model B, the mind isn't really making a decision about the information until the information is integrated. So here we have a model where the brain isn't really taking in each piece of sensory information separately and analyzing each piece, but instead it's looking more of a gist of the information in one nugget and then going from there in the decision-making process. This might be a little more efficient since the brain isn't having to deal with a bunch of extraneous information, but is instead focusing on the collection of the information that might be the most useful. In Model C, we are seeing how the different sensory modalities are actually affecting each other. If you recall from the previous material in the course, our sense of smell and taste do have some interesting overlap, right? Sensory information from one modality can affect the impressions you get in the other modality. And in this model, if you notice, these loops between vision, hearing, and touch, they're looping with each other in bidirectional arrows, meaning that the information is constantly being added to, revised, attenuated, or even strengthened, and that this information might be getting to the decision-making process with ongoing integration that basically does not end. Also, on the right, in the blue text, are some pretty cool ideas to consider. First, research suggests that there might be times when one model seems to be operating and other times when a different model seems to better explain what we are experiencing. In other words, there are probably multiple mechanisms operating at the same time. Also, no surprise here, but we can't rely on people telling us about their experience because most of the time, the information we really want to understand actually happens without conscious thought. Remember how we talked about how scary it is that the brain does a lot of stuff without us even thinking about it, right? And even in spite of some really cool advances in brain mapping and imaging studies like CT scans and MRIs and such, we still don't have any technology that is close enough to what we need to be able to see what the brain is doing in real time on a really global level. We might be able to get snapshots, but even multiple snapshots don't really tell us the whole story, especially when we're trying to understand something super complex like multisensory processing. This is actually one of my favorite topics in the class because it really gets to the heart of what we've been talking about with regard to what the brain does with sensory information and how it makes judgments and informs our experiences. If you haven't watched the video on the McGurk effect, you absolutely must. Just like everyone else, it completely tripped me out when I first saw it. But the McGurk effect is only one of the effects that we could talk about. Our sensory information is from one source affects another source, and again, we may or may not be aware of it. So in the McGurk effect, once again, you're hearing the exact same sound, but in the two different conditions, you're seeing something different, and that visual information is completely changing your perception of what you are hearing or sensing. Like I said, there are multiple examples of this besides the McGurk effect. In the motion perception supplemental video on the motion bounce illusion, the example isn't the best video, but you get the idea that folks might see the first condition as either two blue spheres bouncing off each other, or more likely that they're passing through each other. But in condition 2, when a sound is added and timed correctly, most people then perceive these two spheres as bouncing off each other and less likely to be passing through each other. Finally, there have been some interesting studies about flavor and taste overlap that we sort of touched on in the previous lecture. In one study, the experimenters put red dye in white wine, and the study subjects actually reported tasting elements found in red wine but that are not present in white wine. So again, they were being fooled into experiencing something that really wasn't there just by affecting their visual perception of it. Just seeing the redness of the wine affected their ability to perceive it correctly. In another experiment, when subjects were given a sweet taste, they could taste the substance normally, but when the exact same amount of sweet taste was paired with strawberry fragrance, the participants rated the sweet taste much higher in sweetness. Again, they were totally fooled. So how does the concept of synesthesia fit into this discussion? Well, essentially the sensory information that would ordinarily just influence another sense, like how the McGurk effect shows that seeing someone's lips move changes how we hear something, but with synesthesia, what we have is an abnormal sensory experience instead of just an affected outcome. For example, someone with synesthesia might read words on a page and then actually see their words in certain colors that they're not actually printed in. One of the examples that I personally witnessed early on in my career was an individual who could hear colors. What this meant was that if their eyes saw certain colors with certain brightness and intensity, they could actually hear certain tones. In effect, their brain was relaying sensory information that a sound was occurring when no sound was present. But rather, their visual information pathway was informing their auditory pathway as well. It was totally fascinating. Although somewhat normal for her, she later informed me that there were certain colors that she just couldn't stand because the tone she could hear when looking at that color was just plain annoying. So just keep in mind, imagine how annoying it would be that every time you tried to read something, you heard a tone in your ears that was distracting, or if you saw a certain color, that you experienced a terrible odor that wasn't really there. These abnormal experiences would be pretty challenging. The main ideas are that there are people who are more what we call neurotypical. These folks have developed a group of core experiences that help them to associate different aspects of sensory information. For example, if I look at a carne asada burrito, my brain already knows how good it tastes and might be affecting my taste senses based on what I'm seeing. This is pretty normal stuff for most people. However, for people with synesthesia, they seem to have these incorrect associations from very early on, and probably even from birth, since we see these connections tending to run in families. Thus, they are likely to be genetically linked, at least on some level. One of the useful things about multisensory processing is that even though sometimes we are fooled, generally it has a purpose and is useful and efficient. But with synesthesia, it doesn't really have a evolutionary purpose. It really doesn't help the person with the experience and is often just a big distraction. And finally, with neurotypical people, what we see and what we believe is happening is that with multisensory processing, there might be specific areas or different levels where sensory information crosses over to the other side. In synesthesia, though, individuals have some really abnormal kind of horizontal connections at much lower levels in the sensory information process. So what am I talking about here? Very early on in the sensory information process, one sensory organ or pathway is crossing over with another sensory process way too early, either too early, too much, or maybe both. So either way, there's clearly something very wrong with the ways that these different sensory modalities are communicating with each other to produce these really bizarre experiences